Welcome to the deep dive. We're going to be tackling a pretty big question today. How can we make AI understand information, not just word by word, but like with context, like humans do?
That's really the ultimate goal, isn't it? I mean, to create AI that really gets meaning, not just like strings of words.
Exactly.
Yeah.
And, you sent over some research on something called large concept models, or LCMs, and they might hold the key to this.
They really might. What's so interesting about this is that it moves away from the way we've been building these AI systems. For so long, we've been using models that process text like word by word, almost like putting together a puzzle, but only looking at like one piece at a time.
I see. But what's the problem with that approach? I mean, those models have been impressive so far.
Oh, absolutely, they have. And they're still super valuable. But, imagine trying to understand like a really complex novel. But you could only look at one word at a time.
Yeah, I think you'd miss a lot.
You would. You'd miss like the overarching themes, character development, the nuances, what gives the story meaning. Yeah, and that's one of the limitations we see with the traditional language models, struggling with long contexts and maintaining consistency, understanding the relationships between different ideas.
So how are these LCMs different?
Yeah.
How do they approach language?
LCMs focus on processing information as higher-level units of meaning. Basically, concepts. Think of it like this. Instead of individual puzzle pieces, they're looking at chunks of the picture.
So instead of each word, it's understanding the meaning of like whole sentences or paragraphs.
Yeah, exactly. It's shifting from processing words to processing ideas.
And that opens up a lot of possibilities. How do they actually do this? What's going on under the hood?
So at the core of LCMs is this concept called sonar. It's this high-dimensional embedding space where each concept, no matter the language or the form, is represented as a unique point. Think of it as a giant map of meaning, where every concept has its own location.
Wait, language AND form. What does that mean?
So sonar can actually represent concepts from over 200 languages, and it can handle both written and spoken language. Imagine being able to feed an LCM some text in Chinese, and it understands the meaning, even if it was trained mostly on English data.
Wow. And you said form. Does that mean it goes beyond just text?
It does. Sonar isn't limited to just language. It can work with a lot of things. Text, speech, images, and maybe even other sensory data. So an LCM could understand the concept of cat, whether it sees the word, hears someone say it, or even sees a picture of a cat.
That's really cool. So how does this sonar space actually work with the LCM architecture?
LCMs have two main parts, encoders and decoders. The encoder takes a sequence of concepts, like from a paragraph or something, and it maps them onto those corresponding points in sonar space. It's basically creating a representation of the meaning.
So it's translating the meaning into a map of concepts in this space of meaning.
Yeah, a great analogy. And then the decoder does the reverse. It takes those points in sonar space and translates them back into natural language or potentially other forms like speech or even images.
Okay, so we have this concept mapping with sonar, we have encoders and decoders. I'm curious what the types of LCM architectures Meta AI is exploring. They weren't just working with one type of LCM, right?
Right. They're looking into a few approaches, but the two that are really showing promise are based on diffusion models. They're becoming a big deal in AI.
I've heard that term before, but I'm not sure I totally get it. What are diffusion models?
Imagine you're trying to restore a faded photograph. Diffusion models work sort of like that. They learn how to remove noise from data to reveal the picture underneath. For LCMs, they're using diffusion to learn how to generate coherent sequences of concepts.
So they're creating a clear picture of the meaning from a jumble of information.
Yeah, exactly. So there are two main diffusion-based LCM architectures they've been using. One tower, which uses a single model for encoding and decoding, and two tower, which separates them into different parts.
Okay, so two different architectures. How might that two-tower design, for example, lead to a better AI assistant?
Well, you have more specialized components with the two-tower design. One focuses on understanding the input and the other on generating output. So you could get more accurate and nuanced responses because it's better at processing and generating information.
Interesting. These models must be huge if they're working with all this conceptual information. How much data are we talking about here?
So their initial experiments used models with 1.6 billion parameters and trained them on data sets with 1.3 trillion tokens. That's like millions of books. They even scaled one up to 7 billion parameters and trained it on 7.7 trillion tokens.
Wow, that's a ton of data. How do they make sure the output makes sense and doesn't just, ramble on?
That's where the structure of LCMs and sonar is really important. They use a search algorithm and a stopping criterion based on the concept of end of document. They've basically taught the model to know when it's reached the end of a thought.
So they're not just spitting out words, they're actually understanding the structure of a complete idea.
Exactly. It's a big difference.
We've covered a lot here. The limits of traditional language models, how LCMs use concepts and sonar to understand meaning, even a little bit about their architecture. But do they live up to the hype?
Well, let's look at some of the results from Meta AI's experiments, and you can decide.
Sounds good to me.
So one of the really impressive things about LCMs is their zero-shot generalization performance.
Zero-shot generalization. Does that mean the model can do well on tasks that it's never seen before?
Yeah, exactly. And it's pretty remarkable because the LCMs were actually able to do this across many languages, even beating out traditional LLMs of the same size.
So these models are not only understanding concepts, but they can apply that understanding to new situations, new languages. That's huge.
It is. It's the kind of generalization researchers have been working on for years, and it seems like LCMs are a big step toward that.
I'm looking at some of the examples of what they can do in this research you sent over, and one that really stands out is multilingual summarization.
Oh, yeah.
Can you tell me more about that?
Yeah, that's definitely one of the most compelling applications. What they found was that LCMs could summarize texts in a bunch of different languages. Without being trained on those specific languages, they just used the multilingual nature of sonar.
Okay, so help me understand this. You could give an LCM a news article in, say, Spanish, and it could write a summary in English, even if it's never seen a Spanish news article.
Exactly. And it's not just translating word for word. The model is understanding those concepts from the Spanish article and expressing them in English.
That's amazing. It opens up so many possibilities for communication and understanding across different cultures. I also see this other task here called summary expansion. What's that about?
Summary expansion is a new task the researchers came up with to test LCMs. They gave the model an existing summary of something and then asked it to expand on it to give more details and context.
So like taking a brief overview and turning it into a more complete account.
Exactly. And the fascinating thing is that the LCMs could do this while staying consistent with the original summary. You know, they weren't just throwing in random sentences. They understood that summary and built on it in a meaningful way.
That sounds like a really sophisticated level of understanding. Like it's almost reasoning about the information.
It really does. This goes way beyond just manipulating words. It seems like LCMs are getting those concepts and how they're all related.
Okay, I'm really starting to see the potential. Let's talk about efficiency. How do LCMs compare to the traditional LLMs in terms of things like processing time and the resources they need? Are they faster? Do they need less power?
Well, that's another area where LCMs seem to have an edge. Because they're working with those shorter sequences of concepts instead of long strings of words, they can be a lot more efficient.
Makes sense. So we could be talking about some big gains in speed and needing less energy.
Potentially, yeah. Especially with longer texts or more complex tasks. And another thing, the training code for these models is open source. So researchers and developers can experiment with them and see what they can really do.
That's great for the AI community. More people working on something like this means faster progress. Now I think it's time to step back and look at the bigger picture here. We've talked about how great LCMs are, but how do they stack up against traditional LLMs? What are the main differences and advantages? What are their weaknesses?
That's a great question. Traditional LLMs have been incredibly powerful. They've done amazing things with language translation and even writing creative content. But like we talked about before, they do have limitations, especially with those longer pieces of text, keeping things consistent, and adapting to new situations or languages.
And those are the areas where LCMs really shine.
Yeah.
Because of that concept-based approach.
Yeah, exactly. LCMs can switch between languages more easily, understand information from different sources, even generate content in different forms like text, speech, or images. They're more adaptable.
So is this a whole new paradigm in AI? Are LCMs going to replace the traditional LLMs?
It's really too early to say for sure. AI is moving so fast, there's still so much research to do. But I do think LCMs are a big step forward. They offer a new way of thinking about AI, one that focuses on meaning and understanding.
It seems like they might not be a complete replacement, but a powerful new tool for certain problems.
That's a good way to put it. And both approaches have strengths and weaknesses. The best one for a specific task really depends on what you need it to do. There's no perfect solution for everything.
So I guess the takeaway is that AI is always changing with new things happening all the time. It's a great time to be following this field.
It really is. It's exciting to think about what we might see next.
That's the perfect way to lead into our final thoughts. So we've been talking a lot about the tech behind these large concept models, but What does this all mean for, the average person? What can this tech actually do in the real world?
That's the big question, right? Going from the theory to like what's actually possible. LCMs could really change so many parts of our lives.
Like what? Where do you think this tech could make the biggest difference?
Well, one that comes to mind is scientific research. Imagine an AI that can read and understand scientific papers from all these different fields. Physics, bio, chem, all of it. And it can connect the dots to find new discoveries or breakthroughs.
So it's like an AI research assistant that can help scientists see the big picture.
Exactly. And because these LCMs can work with different types of data, this AI assistant could analyze experiments, simulations, observations, all sorts of stuff, and put it all together.
Wow, it's like having this superpowered research lab right there on your computer.
Yeah. And then there's the creative side of things. Imagine AI that can compose music, write poems, even make movies. And they would understand the nuances of human creativity.
That's pretty wild. So AI wouldn't replace artists, it would work with them.
Yeah. It's a future with tons of possibilities.
Yeah.
But we have to be aware of the challenges too, right? We need to make sure we're developing this tech responsibly.
That's a good point. With powerful tech comes responsibility.
For sure. We have to ask those tough questions now while this stuff is still being developed to make sure it's used for good and, aligns with human values.
It seems like this is more than just a change in tech. It could change society too.
I totally agree. It's a conversation we all need to be having.
Well, that brings us to the end of our deep dive into the world of large concept models. We hope you've learned something new about this exciting area of AI.
And remember, this is just the start. There's so much more to come. We can expect some big breakthroughs in the future.
It's definitely something worth keeping an eye on. We encourage you to check out those materials we've been talking about. Keep learning, keep asking questions. Maybe you'll be the one to discover the next big thing in AI.
Ah.
Thanks for joining us on the Deep Dive.